Hi everybody, Mr. Rubo here. Today we are talking topic 313, which is trigonometry and polar coordinates. So, uh, as it says, up until this point, you've only been doing rectangular coordinate system, also known as the Cartesian plane, where we have an x-axis, a y-axis, and our coordinate points are x's and y's, where we're talking horizontal distance is our x, vertical distance is our y. We can actually use a different way of measuring coordinate points, and this other measurement system is what we call the the polar coordinate system. Okay, so this, instead of saying horizontal and vertical distance, it actually uses just the most direct distance, right, the straight line distance, um, from the origin, and then also the angle measured in standard position. So what we see here is we have this point that's out in space, right? Normally we would say, oh, it's going over X amount and then up Y amount. But in the polar coordinate system, we actually just say, oh, okay, the R value is some value, like some number, and then we have an angle that it is from standard position. So the coordinate points are written as R comma theta, where R, and we'll say the absolute value of r, represents the radius of the circle in which this point would lie, right? So if the radius was 3, it's 3 units away from the origin. And theta represents the measure of an angle in standard position whose terminal ray includes point A. So we usually, what you will see with polar graphs is a slightly different graph paper. Because it is circular based, you'll have circles, right? Cartesian or rectangular, you have squares. Here we have circles. So here we're going to plot some points, and we're going to see how this works. So I'm going to plot and label these following ones on the coordinate grid above. So the first number is our R value. So this means we're looking at on the second circle. So you can kind of see two, like, well, second major circle. So they tick mark this on the x-axis, like what we'd call the x-axis. We're actually going to call it the polar axis, the positive x-axis, if you will. So we're going to go out to 2, but now we're going to go pi fourths on the angle, and we're just going to stay on this circle until we get to that pi fourths line, which is this one right in the middle, and we're going to plot this point. So this right there is A. Okay. Now let's go to B. So B, same circle, so on 2, but now we're going to go negative 7 pi over 4, which means we're going negative, which means we're going all the way around, staying on 2, pretend I'm staying on 2, and eventually we would actually end up in the same spot as A. Interesting. So both A and B represent the same space, the same point in space, but they're written differently. Interesting. So then we go to C. Okay, 2, same circle, but now we're going 9 pi fourths. Well, 9 pi fourths, we're back in the positive direction, staying on this circle, going all the way around. 9 pi over 4 is over 2 pi, and you actually go a little bit more. And there we go, and C would be in that spot as well. And then, so there we have a full rotation, but we still end on the same spot. Now we get to D, and D is an interesting one because we have a negative 2 radius. So with this one, what I'm actually going to do is I'm actually going to measure the angle first. So I know the other ones I did, like I went out to 2 and just measured that. I'm actually going to find 5 pi over 4, find the line. So 5 pi over 4, right, it's the one in the middle in quadrant 3. So it's this one right here. This is 5 pi over 4. But what a negative R value means is that instead of going towards the angle, we're actually going to go exactly opposite. So we're going to go out 1, 2, and it ends up, we're at the same point. So this is kind of one of the interesting things with polar is like one point can be represented in an infinite amount of ways with different R values, whether plus or minus, or different angles. We have positive and negative angles that end up in the same spot. So it ends up, even though these are all different points, They're actually all the same point. They're all the same point in space. All right. We're going to do example 2 real quick, which kind of builds off this. So it says plot the point with polar coordinates 3, 5 pi over 6 on the above grid. So let's do that real quick. So I'm going to go out 3 circles, which is on the very edge, and then 5 pi over 6. These are cut into 12ths, so pi 6 is the second one from the x-axis. So 5 pi over 6 will be the second one on the third circle. So this right here is the point. And then it wants us to write the polar coordinate in 2 different ways. So there's actually a lot of answers here, right? Technically an infinite amount. So I'm going to show you kind of one way is keep the r value the same and then add or subtract 2 pi. So I'm going to do a little scratch work on the side. So 5 pi over 6 plus 2 pi means get a common denominator. That would be 12 pi over 6. And I'm going to add those and get 17 pi over 6. There's one possible answer. I could have also subtracted 2 pi, or I could add 2 pi again, right? That gives me more answers. But then the other thing I can also do is I can make my r negative. And what that does is I now will actually have, in order to end up in the same spot, I would have to be on the angle that's opposite of this, which, thinking about a straight line, that's pi radians away. So in other words, I have to either add pi or subtract pi. So I'm just going to add pi to this. And again, common denominator, we're going to add 6 pi over 6, which means we get 11 pi 6th. And there's another answer. Again, I only needed 2 ways. I can actually keep going. I could add 2 pi or subtract 2 pi to both of these angles and keep getting more and more answers. So polar, a little confusing because of that fact, but it's also really useful because of that fact. So yeah, thanks for watching and have a good day.